Hey y'all. Today we're going to be talking about parent functions. These are some of the standard functions, the simplest forms of them that you should be familiar with in your math classes. We're going to talk about the most common types of parent functions, but we're not going to get into some of the later ones that you would learn in something like a trig class or something like your sine or cosine graphs, or we're not going to get into conic functions like your ellipses or circles or things like that. But there's about 9 other functions that you should make yourself familiar with that you're going to see pop up in your algebra or algebra 2, or even on test prep, like the ACT, SAT, and so on. So we're going to dive into the key bits of information about the functions. So we're going to talk about things such as what the formulas should look like, what you should look out for in a math problem and how to recognize them, as well as the characteristics on the graph, how they look on the graph, how we can manipulate the function on the graph, and other characteristics that you should be aware of. So let's dive in. Starting with linear functions, these are some of the first functions that you start learning about. Linear functions, like the name implies, are straight lines. So on a graph, a typical linear function looks something like this. Excuse the way that I draw it, but this should be going through the origin here at 0, 0. That's one of the key characteristics, that your standard linear function, if we just said y equals x, is going to be a straight line that goes through the origin at 0, 0, and it's going to have a slope of 1, meaning that if you go over by 1 and then up by 1, we get a slope of 1 over 1, or 1. Linear functions are, as I said, some of the first functions that you start learning about. So in general, your linear function should have a maximum exponent of 1. So x, or whatever your variable, is going to be the highest exponent. You shouldn't have anything squared or cubed or anything special like that. As you start to learn a little bit more about linear functions, you learn about some of the different formats that we can put it in. One of the most common ones is the top one here, y equals mx plus b. We call this y-intercept form, or the slope-intercept form. This format is pretty useful because it gives us 2 main bits of information that we use all the time. M here is the slope of the line. So like I mentioned, that's our rise over run. And in the standard linear function, our slope is 1. And then b here stands for our y-intercept. Remember that our y-intercept is the point where the line crosses the y-axis. In this case, since it's going through the origin, that means y equals 0, so our y-intercept is 0 for a standard linear function. The formula on the bottom, you'll sometimes see this is the standard form. So this particular format is really useful if we're trying to find, say, like our x or y intercepts. They give you the value here, which is c, which is basically kind of adjacent to the same b that we had in the slope-intercept form. But one thing that we can do is that if we divide by the a or the b in this format, then that will give us our x or y intercept respectively. So to say, for example, let's say if we had 3xy plus 6, or 3x plus 6y equals 18, that means if I divided by x, I would get x equals 6. And so that would mean that for this particular line, it would plot the line at 6 for x. Let's do a slightly different color, and let's say it's there. And then for my y, I would get y equals 3 when I divide the 18 by 6. So then I would plot it up here, and then I could connect those dots. And that would basically give me my line without having to figure out the slope or the y-intercept specifically. I could just divide by the a and b, and it would give me those numbers respectively. So again, because the a is in front of the x, when I divide by a, it's going to give me my x-intercept, and when my b, because it's in front of the y, when I divide c by b, it gives me my y-intercept respectively. Let's go back a little to clear up this board a bit. So in addition to this, one of the other things that we want to pay attention and be aware of is that with the formula, anytime that you have y or x, keep in mind that those are your actual coordinates for your line. So remember that coordinates on the standard plane are always going to be x comma y. That means that if I had a particular point on my line, let's say we should know that 3, 3 is going to be a point on this line if I drew it properly. Let's redraw it and make it a little bit thicker there. So because this particular line passes through the point 3, 3, that means that 3, 3 is a solution of this line. So anywhere along this particular y-intercept plane, we know that it's y equals 1x plus 0 for this line in particular. And if I didn't have a piece of that information, I could easily put 3 for my y and 3 for my x. And we can see that when I simplify things, 3 times 1 is 3, and y was already 3. So knowing that we have the same thing on both sides of the equal sign, then we know for sure that this particular coordinate is a solution. Same thing if you have a piece of information that is missing within your formula, you could say, take a look at your graph, plug in the coordinate that you have or that was given to you, and then once you plug that in, you can solve for the remaining variable if there's a variable remaining. So let's fill in some of these other details that we have here on the board. So as we said, for a regular linear function, our y-intercept is going to be at 0 because it passes through the origin. Domain, remember that domain is going to refer to all of your x values. So if we're looking at it from left to right or right to left, what kind of x values are we hitting? For a linear function, it has x values all up along the line because it goes forever in both directions when you look at the line horizontally. So we say that that domain goes from negative infinity, coming from the infinity part, and then as we go towards the positive infinity part, it keeps going towards positive infinity. You'll also see that written as all real numbers. Same thing goes for the range. When we look at this particular graph up and down, we see that, again, the line extends in both directions. A lot of people sometimes get sidetracked or confused because obviously this line isn't going strictly horizontally or strictly vertically. That's not necessarily what we're looking at. You're looking at the general path that the line follows as you look up. And as we can see that every part along this line, as you trace it, it hits y values at every single point along this line. And the arrows tell us that the line keeps going to infinity in both directions. So same thing, it hits from negative infinity to positive infinity or all real numbers. End behavior, as we're looking at it horizontally, our y goes up to infinity. So we would say as x approaches infinity, y approaches infinity, and as x, as we go looking to the left, to the negative side, so as our x is approaching negative infinity, the y also approaches negative infinity. So what does that mean? It means that as our x values go up, our y values go up. As our x values go down, our y values are going down. Linear equations are pretty simple and they're easy to understand. Let's talk about the next function.